Hey, good morning to everybody and welcome back to day 2 of the IST workshop on pedagogy for effective use of ICT in engineering education. As we had discussed yesterday, after writing learning objectives at different levels for a given topic, we need to find a way to now put them all together in our course. There were also a few questions on, suppose I write learning objectives for a unit, how do I use those to create my course design or course outline and so on. So what we will do today is look at a technique and a tool called concept mapping. So the technique is called concept mapping and the tools are of course concept maps, which allow us to design our course using the idea of learning objectives. So to begin, what we will do is actually look at this technique of concept mapping using some example that you are really familiar with, and we will also then we will look into how to apply this to your course. And like yesterday, we will be doing this in a partially flipped mode where the content and the information we will transmit using a video, and then we will pause and do some active learning activities and strategies such as think, pair, share and voting that we did yesterday. So the format will be very similar to yesterday, and let's all just get started. So the title of the session is What, Why and How of Concept Maps. We are going to use this idea, this technique of concept mapping and learn 2 or 3 diverse issues related to it. One is the technique itself and why it's useful and how to do it. And second is how do we use it for course design and how do we connect the syllabus and the learning objectives in our course. And thirdly, what technology tools can help us actually create a concept map. So what you have done in terms of course planning so far is we started by discussing and looking at the need for learning objectives. Started with the mismatch between teacher and student and so on. Then you wrote learning objectives for a topic in your course, and today in fact you wrote learning objectives at various cognitive levels for a specific topic or unit in your course. The next steps of course planning is that you need to think about the learning objectives for the entire course or at the course level. What I mean here is that the course, your course or the subject that you are teaching has various modules. Usually it's about 5 to 8 modules per 40-hour course is a very standard number. And then each module has topics or subtopics. Again there are 3 or 4 or 5. So totally there are about 40 or so subtopics, because if it's a 40-hour course, we usually do one subtopic in every class. And what we wrote learning objectives for were at the were at the more detailed specific level. And now we have to think about the entire course and see what is it that we want our students to be able to do at the end of the entire semester at a synthesized level. So before you write your own course learning objectives, let's look at a few examples. So I have examples from 3 different courses, and this example is on fluid mechanics. Again, I have just chosen 3 diverse topics, so let me tell you what these are. So perhaps you will be able to connect to one or more of them. One is on fluid mechanics, one is on basic electromagnetic theory, maybe a first or second year course, and the third one is a first year course on computer programming. So hopefully a large number of you will be able to follow at least one or more than one example. So for this course on fluid mechanics, what the teacher wants the students to be able to do at the end of the course finally is describe physical properties of the fluid and explain the consequences of these properties, state some conservation principles, create models of different types of fluid flow, and determine basic forces and moments acting on different profiles and shapes in a fluid flow. So if you look at these, they are actually at various cognitive levels. The one which says state the conservation principles are at the recall level. So as we are looking at the objectives, let's also try to pinpoint which cognitive level they are at. This is not written in order in terms of hierarchy, but it's perhaps written in order in which they appear in the course. Whereas describe properties of the fluid is and explain the consequence could be at understand level. Determine basic forces could be an apply or analyze level objective, and create models of fluid flow can be at the highest create level. So the other thing you want to observe when you look at course level objectives is that they are written at a broad perspective. It's not, we are not saying any one specific topic or one specific application, but these are techniques and knowledge and skills that we want our students to be able to learn and do after the entire course. So I will just pause for about 10 seconds so that you can read this, and then we will go to the next example. So the next example is a course on electromagnetic theory. Again, this is a basic course, perhaps even at 12th standard in some curricula they might do it, but definitely at the first year level a lot of departments run a course like this. So if you look at how it starts, it says given an electromagnetic field problem. In the sense, all the objectives are with respect to a situation where some electromagnetic fields are described, exist. Given an EM field problem, students will be able to use the principles of electromagnetic theory to conceptually describe behavior of the charges and currents. So the first bullet here is, it's actually at an apply level, but it's saying that qualitatively and conceptually students should be able to reason. The second one says apply Maxwell's equations to quantitatively solve problems, and the third one is derive expressions for energy. So it's only 3 objectives, but this is all the problems and all the examples in the entire course usually will fit either one of these or some objectives that are under these. In the sense, to be able to conceptually describe behavior of currents and charges, the student should know what is a current and what is a charge and should know the laws and so on. Those are not stated here. They will come in the unit level objectives. Finally, last example, and the reason I am showing you all this is because the next activity is where you will write your own course objectives. So in this last example, this is a course on computer programming. It can be in any language, it does not matter. Students should be able to trace code and predict output of a given program. So they should be able to read a program, understand what it is saying, and be able to predict what the output of that program is. What kind of a program? The ones involving pointers, functions, parameter passing and so on. They should be able to write a C++ class for such applications. Here they give an example. They should be able to design and implement applications, that means they have to write large code, and they have to be able to create a simulation for an example like this. So again I am going to pause here, since a number of you might be teaching a computer programming course, so that you get an idea of how to write course level learning objectives. So just so that we are all talking about the same thing, let us take a brief pause here and have you do an activity where you write 2 to 4 learning objectives for your own course. You saw 3 examples just now in different areas, and again yesterday a number of you said that you wanted to look at learning objectives from various domains, different domains. So this was one such attempt at giving examples from various domains. So take about 2 minutes. If you would like to pair up and talk to a colleague, that is also fine, and write about 2 learning objectives for your own course, and then we will proceed after this. If you would like, you can share it through chat. It is not essential to do it, but take about 2 minutes to write learning objectives at the course level, which is not the same as at a topic level. If you have written the objectives for your course level, let us see what a teacher needs to do next, because what we have to do at this point is be able to connect the kind of objectives that we saw yesterday with what you will be doing today. Okay, so let me just read out a couple of learning objectives that you are sending us on chat. One of it says that at the end of my course on data structure, students should be able to implement various operations on basic data structures. So yes, this goes beyond one single class,
and you can consider this to be one of the broader objectives for your course. Students should be able to analyze, do functional analysis of various circuits. So, these are just a couple of examples of objectives for your course. Again, I would like to remind you that try not to use action verbs like understand, because if you say something like students will be able to understand the logic, it is not a performance outcome and it will be very hard to measure it and give exams that are aligned to it. So, now let us see how to align course level learning objectives with the topic level learning objectives. So, the next video is going to be played now.
So, let us go to the next point now. So, now here is the situation that a teacher faces, where most of us are at this point, that you wrote learning objectives for specific topics and modules, you also wrote learning objectives at the course level. But the next point all of us need to pay attention to is make sure that the topic level learning objectives and the course level learning objectives are aligned with each other. Because one is at specific level in the course, the other is for the course as a whole. These cannot be independent, they cannot be separate, and they have to be exactly aligned to each other. So, this is one requirement that the teacher has to fulfill while doing course design. The second requirement is that in most courses these days, 40-hour course, semester long course, complicated topics, you have a large syllabus, lots of topics, and not just lots in terms of numbers, but there are lots of interconnections between these topics. And what we want students to be able to do is actually see these connections, make these connections themselves between the different topics and different concepts in the syllabus. So, as an expert in the domain and as a teacher, you have an idea of what these different topics are and how they connect. But for a novice student who is learning it for the first time, being able to see these interconnections is not very easy. And when we think of our syllabus, even if we print it out in 3 or 4 pages and give it to a student, a syllabus has a long listing of topics, one after the other. And what's missing in a syllabus is these interconnections for a novice. As an expert, I am sure you can do it. So, there is a problem, or not a problem, there is something lacking in a syllabus the way we write it, even though the syllabus is where we start. One is that the syllabus does not have these objectives and it is a little hard to align these if all we have is the syllabus. And secondly, these interconnections are not clearly visible in the syllabus. So, what is needed is a back and forth connection between the learning objectives at all levels, at all cognitive levels, as well as at course, module, unit, class level, and the syllabus. So, these two ideas, these two concepts, so to say, have to be interlinked. And so far what we have done in all these sessions, what we do is first we set up the problem. We say here is a situation faced by the teacher, here are some gaps or here are some needs, and then we think of the solution. So, here the situation faced by the teacher in this slide is actually the problem, and one possible solution is actually given by the concept map. So, what the concept map or the technique of concept mapping helps us do is fulfill these requirements that we just talked about in the previous slide. These are the same requirements that teachers need to make sure that the learning objectives at course and module and unit levels are all aligned, and students should be able to see the connections.
Okay, so what exactly is a concept map? And many of you would have drawn informal diagrams which depict the organization of your course or a similar goal, but a concept map has some specific requirements, and we will look at those requirements through an example. Concept maps are defined as their purpose is that they provide graphical tools for organizing and representing complex knowledge where there are lots of interconnections, as we just discussed. And concept mapping is a technique to understand these relationships between the various key ideas of this larger complex concept. And the ideas, this technique is implemented by creating a visual map or visual diagram of these connections. So, let us work through an example where we want to draw a concept map for what are the various parts of a computer in order to illustrate this technique of trying to understand relationships between various ideas within a complex concept. So, the first step is to first list all the various parts of a computer. So, I will just show you how it is listed here. You can write it or you can draw it, it is really up to you how you choose to do this. And at this stage it does not matter what order you do it in, just list all of these, and then at the next stage what you want to do is organize this list of unordered list of concepts that we had in the previous slide into some sort of hierarchy. You can decide what kind of hierarchy you prefer to choose. Here that is why different people might draw different concept maps and various representations may be valid. If you look at the hierarchy that has been used in the slide, you will see that the broad categories of hardware and software are there at the top. Then the parts such as CPU, memory, which are also somewhat general, are there in the middle layer, and specific examples of hardware, specific examples of application software, of devices are there at the bottom layer. So, at the second step of concept mapping, you take all the concept and organize them in an order such that the top level is broad and general and the bottom levels are specific and are examples of the top levels. At the next step, what is done is these concepts which were there in the previous slide are connected again roughly in this order. So, you may not be able to see this, read the details of this concept map, but if you, and I am going to zoom into different parts in a minute, but if you later look at this, what you will see is that hardware and software are here at the top, and even above that there is computer. And the examples that you saw earlier, like memory can be a RAM or a ROM or a hard disk, they are there all the way at the bottom. Device, input device comes somewhere in the middle and examples of input devices come below it. So, it is the same diagram as the one you saw earlier, but now it has been connected using different links. So, now let us zoom into various parts of this concept map to understand what are its features. Start from here. Computer consists of hardware and software and so on. Note that the concepts, which are like some objects, some things, are usually enclosed in circles or boxes. So, let me read out some of these concepts here: computer, hardware, software, operating system, input device and so on. And these are the same concepts that we identified and organized a few slides ago. What comes next? These concepts are connected by links, and links are essentially lines, they are arrows which connect one concept to another and they show the relation between the concepts. On the link there is something called a linking preposition. These are words or phrases which specify the exact relationship between two concepts. So, let us look at these two examples. Computer is connected to the concept of software through the preposition of consists of. So, computer consists of software. Hardware is categorized as input device, and I think down here comes output device. So, you can have different types of prepositions. Some common examples of these prepositions are consists of, classified as, are examples of, is the reason for, and so on. So, we have concepts, we have links which are arrows, we have linking prepositions, and then we have something called cross links which link concepts horizontally far away from each other. I will zoom out again after some time and do a back and forth between the zoomed in and the zoomed out version. So, to summarize, a concept map has the features that it is a visual representation depicting the hierarchical organization of knowledge. There are prepositions that link to concepts, and most importantly, these prepositions need to form a meaningful statement. Usually concept maps are top to bottom, and usually we don't have loops or backward arrows. So this is not like a flow chart. So what is a meaningful statement? I'm going to put back the slide where the entire concept map was present, and it's okay if you cannot read it right now. I'll just read out one or two of these sentences, meaningful statements, and what you can do later when you have access to the slides is to actually look for these statements. Okay, one meaningful statement is that computer consists of hardware, broadly classified as output device, which has examples of printers and display units, connected via motherboard to output device and to CPU. So if you just followed the pointer, it went like this along all the links to form a meaningful statement. So what we'd like to do is a think, pair, share activity where we'll have you watch a short video on a topic which may be interesting to many of you. It's the use of haptics, and it's a TED talk. We'll post a link to the video in a minute. So watch the video and in pairs draw a concept map, and then we'll do a peer review of the concept map. So you can watch the video and take about 2 or 3 minutes to note the key concepts, and about 5 minutes on the pair phase. So we'll post the link just now. Just before I play the video, let me explain what this is. This is not a video about concept maps. It's a video, it's a TED talk, it's a video on some new topic. Assume you're learners of this new topic and you need to draw a concept map about the concepts in this video. So watch this video, we'll play it from here for about 3 minutes or so, and then note down the concepts and create a concept map which represents the concepts and the ideas in this video. So watch this video from a learner's perspective.
I'm a mechanical engineering professor at the University of Pennsylvania, and my favorite hobby is photography. And as I travel around the world, I love taking photographs like these so I can remember all the beautiful and interesting things that I've seen. But what I can't do is record and share how these objects feel to touch. And that's kind of surprising because your sense of touch is really important. It's involved in every physical interaction you do every day, every manipulation task, anything you do in the world. And so the sense of touch, it's actually pretty interesting. It has 2 main components. The first is tactile sensations, things you feel in your skin. And the second is kinesthetic sensations. And this has to do with the position of your body and how it's moving and the forces you encounter. And you're really good at incorporating both of these types of sensations together to understand the physical interactions you have with the world and understand as you touch a surface, is it a rock, is it a cat, is it a bunny, what is it? And so as an engineer, I'm really fascinated and I have a lot of respect for how good people are with their hands, and I'm intrigued and curious about whether we could make technology better by doing a better job at leveraging the human capability with the sense of touch. Can I improve the interfaces to computers and machines by letting you take advantage of your hands? And indeed, I think we can, and that's at the core of a field called haptics, and this is the area that I work in. It's all about interactive touch technology. And the way it works is you move your body through the world. If, as an engineer, I can make a system that can measure that motion and then present to you sensations over time that kind of make sense, that match up with what you might feel in the real world, I can fool you into thinking you're touching something, even though there's nothing there. All right, so here are 3 examples, and these are all done from research in my lab at Penn. The first one is all about that same problem that I was showing. How can we capture how objects feel and recreate those experiences? And so the way we solve this problem is by creating a handheld tool that has many different sensors inside. It has a force sensor, so we can tell how hard you're pushing. It has motion tracking, so we can tell exactly where you've moved it. And it has a vibration sensor, an accelerometer inside, that detects the shaking back and forth of the tool that lets you know that's a piece of canvas and not a piece of silk or something else. Then we take the at data that we record from these interactions. Here's 10 seconds of data. You can see how the vibrations get larger and smaller depending on how you move. Then we make a mathematical model of those relationships and program them into a tablet computer so that when you take the stylus and go and touch the screen, that voice coil actuator in the white bracket plays vibrations to give you the illusion that you're touching the real surface. Just like if you touch, drag back and forth on the real canvas. We can create very compelling illusions. We can do this for all kinds of surfaces, and it's really a lot of fun. We call it haptography, haptic photography, and I think it has potential benefits in all sorts of areas like online shopping or maybe interactive museum exhibits where you're not really supposed to touch the precious artifacts, but you always want to. The second example that I want to tell you about comes from a collaboration I have with Dr. Margaret Maggio at the Penn Dental School. Part of her job is to teach dental students how to tell where in a patient's mouth there are cavities. And of course, they look at x-rays, but a large part of this clinical judgment comes from what they feel when they touch your teeth with a dental explorer. You guys have all had this happen. They go across. What they're feeling for is if the tooth is really hard, then it's healthy, but if it's kind of soft and sticky, that's a signal that the enamel is starting to decay. And these types of judgments are hard for a new dental student to make because they haven't touched a lot of teeth yet. And you want them to learn this before they start practicing on real human patients. And so what we do is we add an accelerometer onto the dental explorer, and then we record what Dr. Maggio feels as she touches different extracted teeth. And then we can play it back for you as a video with a touch track. So not just a sound track, but also a touch track that you can feel by holding that repeating tool. You can feel all the same things that the dentist felt when they did the recording and practice making judgments.
Okay, so you saw about 4 minutes of a video on how haptic technology is being used in different examples. So can you try to represent the ideas that you learnt in this video via a concept map? And assume that you have to tell your friend who did not watch this video what the video is about. So instead of describing it to them, you draw a concept map to explain to them what the video is about. So take about 5 minutes to draw this concept map, do the think and pair phases, and then we'll see how to evaluate the same concept map. You don't have to get exactly all the concepts right. You can focus on whichever part you thought was more interesting. Some of you are asking that you want us to play the video again. Instead, what I've done is I've posted the link in the chat forum. If you'd like to watch it locally, please go ahead and do it. And even if you got the idea for a small part of it, that's completely fine, because what we want to focus on now is not the technical details in the video itself, but how to use this technique of concept mapping to depict some new ideas. So I've posted the link on chat. If you'd like to watch it again, please do so locally. Okay, so it's sufficient if you have drawn some part of it, and some of you have been asking just now in the chat window, what is the point of doing concept maps for specific topics and how is it related to course design? So let us look at these two questions once again, and especially connected to your course design. The purpose of the video was to just to give you an idea of how to take a new topic and draw a concept map from it. So why to use concept maps and who's supposed to use concept maps? As a teacher, you can use concept maps for various purposes. You can use it to explain a new topic in class because it helps students see connections between ideas, connect new ideas, organize ideas, and so on. You can also ask your own students to create concept maps, which will help them do exactly the same points, that if students already have some ideas, concept mapping is a technique that will help them connect the new ideas and organize these ideas. So when you draw a concept map, usually the way it is evaluated to see whether somebody has drawn a useful concept map or if the concept map needs to be improved, there are 2 or 3 items on which a concept map is evaluated. And we will not do the share phase right now, but all I will say is that there are 3 main points related to the connections between the ideas and the organization of the ideas which are used to evaluate a concept map. So as a teacher, when you are explaining a new topic, instead of verbally explaining this is one technique you can use. You can also tell your students to use this technique for them to understand a concept map a little, understand a new idea a little more clearly. And finally, you can use concept maps to create a big picture of your course by establishing the links between the various modules of the course. So, this is where the objectives and the course planning comes into play. You have learning objectives at various levels, you have learning objectives for various topics and various modules. So, when you need to make decisions such as how much time should I spend on a topic, how does one topic relate to another and so on, you can create a concept map and use that for the rest of your course in order to make such decisions. So, how do you create a concept map for your own course? You first list the key concepts or the topics and the topics in the course. Identify the most important or the most general concept, then the next most important, and organize it hierarchically. At the top you write the general one and at the bottom you write the specific examples. And then link these concepts using lines the way we did for parts of a computer, and check if there are relationships between the concepts that are far away from each other in your course. Draw these lines. Once you draw these lines, when you are teaching one of the topics, you will remember that you want to actually mention the connection that this topic had with some other topic which was discussed at a different time in the course. So, we will play a video which has an example of this in electronic circuits. We will play a few minutes of this video.
What I would like you to do now is read this list, and my colleague Madhuri Pavanpurre will do an example for you on how to construct a concept map, and she is doing it for her course. So, she will in fact follow these steps in order, and as she is doing it, you can try to connect it to these ideas. So, first what she will do is identify key concepts in her course, and then she will, let's do 2 steps and then we will come back to this slide. So, she will identify the key concepts and then she will rank these concepts from most important or most general to the next most important and to the next most important and so on. So, tell us which course you are doing and what the concepts are.
So, I am starting with a digital logic circuit, the same course where I have given example for learning objectives.
The first step is identify key concepts in your course.
Yeah.
So
the course is on digital logic design. So, the first one is a digital logic circuit for which I will write, this is a course for which I will write key concepts, or we can say that since we are generating it for a course level, definitely the modules which will go and what are the lessons. So, in order to write key ideas, I will just start writing key ideas. When I talk about a digital logic circuit, the key ideas will be, one of them is sequential circuits, then there can be combinational circuits, then we can write basic gates, so you can see that I have listed few concepts here for digital logic circuits. It can be sequential circuits, it can be combinational circuits, then basic gates, number systems, truth tables, flip-flops, then basic gates like AND or NOT gates, or it can be even universal gates like NAND, NOR gates. There can be finite states machines, then arithmetic circuits will be there, multiplexers, demultiplexers, then there can be decoders, there can be binary, octal, hexadecimal, or even conversion of systems and arithmetic circuits. So, these are the key concepts or the key modules which I have noted. Now, the next step in drawing concept map, that is the next step. I have to identify which are the major modules or the important modules that I have to write down first. So, I have written few of the modules as a first module, or I will write it here. So, after writing this concept, the first one or first module which comes to my mind is the number system, and definitely it is as per syllabus. So, this will be the first module. Then comes the basic circuits, or I can say that logic circuits. That is the second idea. The third important idea is the combinational circuits. Now the fourth important idea is the sequential circuits, and the last one are the memories. So this is how from the digital logic circuits I can write this as includes number systems, logic circuits, combinational circuits, sequential circuits and memories. So these are the most important modules which are there in the course of digital logic circuit. Now further to write a secondary level concept in number system itself, I can further write as classified as, this is a preposition. Now number system is classified into binary, then octal, then hex system. So definitely as a teacher, if I start with this module, then the next part which I will follow is teaching these systems, that is I will teach all these number systems. If I take a second module suppose, then what I will write is logic circuit includes basic gates like then all and, or, not and universal gates as well. So this is the secondary level concept in the concept map. Now in order to, if I just follow this link, now this basic gates, how am I going to realize them? Realize using truth tables. So this is one link which I will follow.
I just want to make a quick comment here. See, when we are showing the example, it's not so much to teach you what are logic circuits. So we are not trying to focus on the content. We are picking a topic which may be familiar to at least half of you, but even if you are not exactly familiar with the circuit, what you want to try to follow in the demonstration is how, starting at a general or topmost topic, one can draw a concept map all the way to the to the more specific topics. So even if you don't understand the topic, you should be able to follow the key ideas of drawing the concept map. And if you look at the demonstration, if you look at this, you saw how, starting with the top, the four most general topics were identified. They were drawn, circles were put under, a preposition called includes was put on the top, and then logic circuits was then further detailed. There was a preposition, another preposition called includes, next set of concepts, another preposition called realize, and the final set of concepts. So this is the type of, this is what you want to be able to see. So right now we'll do one more such branch, and then we'll just connect it to learning objectives.
Now if I select, now this is being the fourth chapter in the module. Now sequential circuit contains flip-flops. So this is another concept. Now in order to realize this flip-flop, you will require concept of basic gates as well. So this is being a second chapter. Flip-flops can be realized. So basic can be, or you can say that basic gates can be used for flip-flops. So here is a cross link, that is if you teach basic gates, student will able to realize flip-flops as well. So there is a connection between the second chapter and fourth chapter. If we, so this is a cross link actually. So from basic gates we can say that flip-flop can be realized. So which are the part of chapter number 4. So this is known as a cross link.
Here earlier, the only thing I'd like to say is that in this live demonstration, what you should have seen is that starting at the top, there were next level concepts identified, prepositions included, and then cross links between topics a little far away were put in. So when you do your course design, this is exactly how you will do it. From the top, go down all the way at the bottom.
So for digital logic circuit, suppose there is one of the course objective is design of, student will be able to design different digital circuits, okay, circuits. So design of a digital circuit, if it is the course level objective, now in order to fulfill this course objective, I have to include which chapters. I need a logic circuit, I need a combinational circuit, I need a sequential circuit. So at logic circuit level, I may include recall and understand type of learning objectives. Like I will first, this is being an introductory chapter, I will write that student will able to draw logic diagrams, they will able to write truth table, or they will able to even construct a logic diagram for given situation. Now once they are able to do this, then once they know how to do logic diagram, then here I may introduce, they may able to implement circuit or arithmetic circuit. So this is little bit at higher level, apply level. So probably I will choose only 2 learning objectives here, and in order to develop this chapter, I will go to the apply level. So there is a possibility that one design level course objective can be fulfilled using chapter 1, 2, level 1, 2, chapter 3 using 3rd level, chapter 4 or 5 I may go with the higher level. So this is how I can split one course objective into different levels across different chapters. So it is not necessary that I will try to fulfill this learning objective or this course objective using only one link. There are links between the content. So for every lesson I will try to set up a learning objective which will ultimately lead to the final course objective.
Okay, let me first address a couple of queries that came on chat related to this video. One point is that when you try to draw concept maps either for a new topic or try to connect ideas that you have or try to draw a concept map for your course, there is no single correct answer. It is not like an objective question which only has A or B as a correct answer. I mentioned this even earlier that the concept map that you draw may be somewhat different than the one that your colleague draws. Both may be valid. What is important, however, is whether this concept map captures all the connections between the various small ideas within the complex topic, and whether there is a logical flow of the ideas from the top to the bottom within the concept map itself. So it is completely okay to have a different concept map than the one that Madhuri drew here for the same course or for the same topic. The second point is some of you actually have written, why should we draw a concept map when textbooks do the same thing? And the point here is that textbooks do part of the same thing. So until the topics are listed and ordered in some manner, the textbooks, in fact, the good textbooks do the same thing and they do a good job of organizing the information. But as an instructor, you may choose or you may need to choose only some parts of the textbook for your course, only some chapters, or you may have a goal for which not every chapter in the textbook provides the information that you need. So based on your course objectives, how do you choose which chapters of the textbook you need to cover, or how do you choose which learning objectives to cover in which topics, like Madhuri did towards the end of the video. Those are the questions to which concept maps can help you come up with systematic answers. So this is a technique which perhaps many of you do anyway, but concept mapping gives you a slightly more systematic method because it allows you to explicitly draw the connections and realize that in order to teach a design problem in week 8, I need to have covered the apply level objectives in week 4. So concept points and statements such as this is what concept mapping will help you to do. This is again another tool that you can use in your course design. And like we discussed in the evening session yesterday, the purpose of this workshop is to expose you to a large variety of instructional strategies as well as technology tools, and then you can choose the ones that are useful to you for your course and for your students. So let's stop here for now.